Hello, everyone. This is the Working Group Device Management meeting from July 8th. We fall under the CNCF Code of Conduct. Please remember, be kind to each other. And we do have a few topics on the agenda. Before we start, let me just ask around, do we have any new participants who want to say hello or introduce themselves? Now would be a good time. Just raise your hand. Yep.
ఏం అది తింటావా? అది నువ్వు తినలేవు, గట్టిగా ఉంటుంది అది. తింటావా?
I
గట్టిగా
think you are not on mute. Let me fix that for you. Okay. I think that was not meant for us. So no one else. Then let's get started with the agenda. I don't have it on the meeting agenda. Just a quick status update. We are aware that Code Freeze is coming. We are working on promoting DRA to GA. And as I announced on Slack, I think I have all the PRs ready for it. I just saw that John had some comments on the V1 graduation. I'm going through those. Other than that, it's a matter of API reviews now for the graduation and readiness check. So we should go through our pending tasks. To the best of my knowledge, the last remaining open one is scale testing, but we don't seem to have LA here today. So that'll have to be done. Oh no, here it is. He is. Hello, LA. I was just talking about GA graduation and whether we are ready for it. So perhaps you can add a topic for your update on the scalability. I'm not sure. Shall we do that now? Can we do it now?
Um, hey guys, can you hear me?
Yes, we can.
Yeah, sorry, I was a bit late. We can do it in this meeting. I'll just need 5 minutes to organize data.
Yeah. Okay. Then we'll go through the others and make sure that you get at least, I don't know, 15 minutes.
Sure.
Yeah. Good. Then let's cover the other ones first. Kevin, I think
Yeah.
you are next, so over to you.
Do you mind if I get share access? I have a couple tabs I want to give an overview on. Thank you. So I've kind of been playing around, thinking a little bit about next steps for in-place pod vertical scaling. And so basically the problem I was seeing is like, if you want to use in-place pod vertical scaling with workloads, there's a lot of assumption that the pod templates are immutable. I think for devices, we have a much longer path to have, resizing of workloads while they're running. But I was kind of thinking about like the lay of the land for how, like, as like, let's say somebody wants to modify an existing job. I view there's kind of two states that the job can be in. One is suspended, and this is kind of a common path for queue, where like you have you submit a workload, and then queue gates it and waits for capacity, and then it gets resumed, and then it continues and executes. Right now, there is a problem where it's not. I guess it's a feature, right, or whatever. It is what it is. But when a job is suspended, you are only allowed to change scheduling requirements like node selectors and I think label. Or there's a couple of options that, and this is due to a KEP from a few years ago, where you can change like node selectors and stuff like that, but you can't change anything in the pod template. So I've kind of been floating the idea of relaxing pod templates updates on jobs while a workload is suspended. I've been kind of going through, and I have a POC where I've worked on this. But why I'm coming here is, for the first case, I'm going to call it traditional resources like CPU, memory, and even GPUs. While you're suspended, you can always change like, device plugins or classical resources without any issue. But what is interesting problem for this group is, what do we want to do for DRA? So my idea was, for a pod template, you kind of have two ways to change a workload's resources for DRA. You can either patch the pod template to point to a new claim, or we could go with people changing the resource claim template and treating the pod template as immutable. I am kind of like for the KEP, when I was working on this, and this is for 1.35, so hopefully I was not really thinking about DRA at the moment, but I was playing around with it, and I know that like with DRA, we don't allow like you can't change a resource claim template right now because it's immutable once it's created. It doesn't matter if it's used or not. And then also you can't change the pod template to point to a new claim. So I was wondering, like, what path forward do we want to do for DRA for like when workloads are not scheduled or running yet, but someone may want to change the claim?
First question, have pods been created already at that point?
And suspend, like, let's do the fresh state. A job is suspended. There is no pods created, and nothing is using the resource claim. So you're on mute, Patrick.
In this case, you can just delete the resource claim template, replace it with an updated version under the same name, and then when pods get created, they will use the updated resource claim.
Yeah. Okay. So you're saying that, I mean, that is a path. So if someone wants to change it, they can just change they can delete the resource claim and recreate it, and there's no reason really to have to support the update.
There's no reason not to do that either. It only works, of course, if you are sure that no resource claim has been created from the old version, because that would continue to be used for the pod. It would be listed in the pod status as the claim to use, and there's no mechanism to reconcile with an updated resource claim template. That's the reason why a resource claim template is currently immutable, because if we waited immutable, it probably wouldn't have the desired effect in many cases.
Is there any interest though in having people be able to change a claim on the pod template or the pod spec? I guess there's a big issue.
At runtime, when the pod has been created?
Well, you could argue if it's created or if it's scheduling gated.
Well, the reason why there is interest, sometimes people are annoyed because the fields are immutable and they have to use this workaround with delete and recreate. So there is interest. The problem is, if we lift that limitation, we have to think through all the implications of what is the expected outcome in the different pod states, whether it's gated or whether it's scheduled. How much do we want to propagate that change into the running system? And that is a larger problem that hasn't been tackled yet.
So the workaround I guess the problem here is if multiple people are referencing a single claim, they would not be able to delete it, is the only issue here, right? Like if people are sharing the same resource claim,
yes,
you will not be able to change it. And
you can change it if it's not allocated. So if it's not allocated, you can delete and you can recreate it with a different content, which goes back to the question: is that resource claim in use? If it's referenced, it's not locked. You can still edit it or replace it.
Well, yeah, I'm saying like maybe there's a case where you have like 3 jobs where 2 of them are running, pointing to an existing claim, and you have one that's suspended, and maybe you want to patch that one to, or you're thinking maybe I want to, change that one job, but if the other 2 jobs are using that resource claim, you have to treat that entire thing as immutable, right? Because it's being in use, and so that's the only downside. Well, I can always just document that as like how to support this for DRA. There was a question in SIGAPS for this for suspended jobs about a similar problem. There is like you can always delete and recreate. So why should we add this feature? So I'll probably have, and so I guess that is a good point again, that like why, like there's always this case of, you know, delete and recreate is fine for these cases. So, but I guess that we do have a path forward. Then we can always just, if they're not in use, delete the resource claims, and we don't have to relax anything about the immutability. And I know that right now, I don't think we don't have the bandwidth to think about like changing the resource claims on a running pod right now. I think that is kind of a much harder problem. It sounds like to me.
It's much harder, and we don't know whether we can even do it with CDI and container runtimes as they exist today, or with the hardware that would be used with DRA.
Okay, that makes sense.
Ale?
Yeah, I just had one comment that a lot of ecosystem projects, I'm at least aware of two, like Q and KubeVirt, are making assumptions on that immutability of resource claims. So if there is a need to change it, it would be preferably better to do it sooner rather than later. Because once these ecosystem projects go to beta or GA with DRA support, then it would be really hard to absorb the immutability change in the core APIs.
Yeah, I don't see us doing that anytime soon.
Okay, that is
If
reassuring.
ever.
Thanks.
Yeah.
Well, I mean, I guess it does feel like there definitely seems to be interest in the in-place pod trying to do that. Are we saying like we don't want to support resizing of devices at all, or we don't have the cycles to do it right now?
We
I
don't
don't
have
think
a
the
demand.
runtimes support it. I think that's the bigger issue.
Yeah, but I mean, we're all like we could work towards making that happen, right?
I see. So for what you mean, not just Kubernetes changes, but if we pushed it all the way down the stack.
Because like I'm thinking like to me there's I this is a hard problem and we can't solve it like in one KEP cycle, but I mean like is there interest in having a discussion to try and allow for dynamically changing resources on running containers?
I haven't seen much demand for it.
Yeah, I mean, why this comes up in my case is I was brought up like people finding like GPU utilization, like people are sitting on like, let's say they request 4 GPUs and they're running and they find that they're actually not using all 4. They may want to change the request to use 2 and leave one available for someone else. But I obviously like it's not supported at all right now. And I've seen some people ask for that, but
This request comes up fairly often. Yeah. The solution we usually give them is to, at least today, is to oversubscribe the GPUs to multiple pods and then coordinate through some other means to make sure that only one of them is using some subset of them at a time. It's not ideal, but we're also working on ways to improve our MPS server. If you're familiar with MPS, to allow us to have more controlled release of some of the GPUs so that you can oversubscribe them, but they actually guarantee that only one of the containers is accessing them at any given time. But the more intuitive API would be what you're describing, where you have some and then you release them and then someone else can pick them up instead of having to do some kind of out of band coordination between all of the different pods.
Yeah, well, yeah, because like this is sort of why I decided to take this feature as two approaches. Whereas if they're not running, we can always. I was thinking it would be, from a suspended job. I see no reason why someone can't patch and change, at least for traditional resources. They should be able to change those. It has never been scheduled or started, but I can understand why for running we have to. This is much harder problem. I'll just kind of update the KEP on the findings here to kind of say like what the recommendation would be for DRA for now, and then we can maybe have a discussion about relaxing immutability when we have more, maybe as like we start adding support in the run times to allow for this. But right now it doesn't sound like we're anywhere close to having that change in Kubernetes. Well, thanks everyone. We can go on to the next topic. No other questions.
Yeah. If you make me the host again, or I stop sharing, I can bring up the agenda. Now, right now, I can't share. I think you still have that right.
I made you back the host.
Okay, then I'll bring up the agenda again. Not much on it, but just for the sake of it. Okay, yeah, Gita, you are next.
Yeah, hey. So I had two things to bring up. The first one is question about the partition-able devices. Let me share my screen real quick. Oh, it's not letting me. Okay. So the question is, there's a training job which spans across multiple multi-host servers. What's the UX for allocating that training job? Say I'm using two things. I would bring up job set and then MPI job. I'll pause there. I can clarify the question if it's ambiguous.
No, I think it's clear. There is one open issue from John about job to support creating resource claims, which is needed, I think, for coordinating the connectivity between different ports running on different nodes. And that's pretty much the only thing that we have going on in that direction right now.
I think you're talking about this one.
Yeah, you can share. I made you host.
Yeah, Kevin already posted that. So that will fix it only for job set though, right? There are other constructs that people use.
Yeah, all of them eventually will need to have some kind of control of resource claims, I suppose. But I haven't looked much into that myself.
So for say 134, we go GA, and people want to run this use case without developing anything additional for it. What UX is possible? Only thing I'm able to find is like the topology key, perhaps all of these constructs have it, but that requires node labels and stuff. So
I don't think there's a generic way to do it. I think that's kind of the issue. That's why they brought it up for job set. And I think it was a while ago now, but I remember commenting on that saying that job set is just one example of lots of them, as Patrick just said. But even adding it there, then that means it only solves it for that one and not in general.
Yeah, we're seeing I see a request for this in leader worker set and job set, and I've been a little confused on whether or not this is possible to do with like DRA APIs as is. So the author of that issue, or sorry, someone who created that issue, there's a KEP for it in job set. I've asked them to kind of work on like a proof of concepts before we commit to like a design or implementation of how this would work in job set, because I know I've been seeing a lot of other KEPs from DRA calling this issue out as a motivating use case. So I'm a little confused on like, are all the APIs there that we need to do like what you're asking for? And then is it just adding an API at a higher level in a controller. I'm not sure.
But I want to second what Kevin said, like job set is not the only thing, right? Customers are using other constructs as well. So we probably need to address for that as well.
Yeah, and I
But
think
MPI job happens to be popular.
Yeah, Kevin has, he posted an issue there where I think the challenge, what I found is like leader worker set is one example, but leader worker set is based off stateful set. And for some reason, a stateful set might have a different requirement than leader worker set. And what we have found is that like you can add this at the job level, but almost at the same time, you probably also want it at the higher level workload. Like an MPI job might have a very different way of sharing these resources than a batch job would. And so it does kind of get into a bit of a chicken and egg problem we have right now, where like we could add it at like the job level and that means job set uses it. But I don't know if like we can get away with not having that API at the job set level either. And from leader worker set, I've heard that even though you could add it at the stateful set level, there is still a reason why you'd want it at the leader worker set API level too. So kind of the conversation just has to kind of be started and implementation wise on some of these, unfortunately.
So stepping back a bit, post GA, if we could say we have to develop something for it potentially, then how are people going about it? We combine whatever is being asked for into single, because resource claim template is not coming in at the right level. Either we have to publish too many devices or change something about what the device means, publish it granularly, that is, or we give it as a claim. When we give it as a claim, there is a problem because you cannot give two independent ones in the same resource claim. They have completely disjoint set of nodes.
Well, I think the solution is that someone needs to look at these problems and come up with a cap if it's a workload controller that sits in Kubernetes, or if it's something that sits on top of Kubernetes, address the problem there. If we need, well, one thing that I can see as something, a blocker for some of these problems and that might need work in Kubernetes is moving coordination between different resource claims or devices across resource claims up into some other entity. We've not done that before. Say, for example, if a pod references multiple claims, we allocate all claims together, but we can't put constraints on all devices across the different claims, because that would have implied in the past putting beta or alpha quality fields that are fairly complex, like the constraints, directly in the pod spec. And it might not even be the right solution for a higher level workload. So that's why we haven't done it in the past. Now that we are GA, we could consider taking some of the ideas and features that we have at the claim level and move them up the stack into the pod, into job set. Well, job set is problematic because that's not visible to the kube scheduler, but it could go into some kind of pod construct. But yeah, this I think is an open problem that still needs to be worked on. But going GA with core structured parameters, I think, is a precondition. We can't even start thinking about touching the pod spec with fields that are as experimental as they were just 2 releases ago. The bar for pod spec changes is much higher, I believe. And experimenting is harder there.
Mm-hmm. So I guess for now, I can probably file an issue. I expect this to be a common case, right? Training job spanning multiple of these multi-host devices. And it would be ideal to have a native UX on this instead of every vendor developing something to solve this.
The problem is that in Kubernetes, we don't really have a set of pods as a concept. And Zig scheduling is working on that, but that goes beyond just the array support. It's a general problem in Kubernetes.
Yeah, I was going to say that's like the workload aware scheduling issue that just came up this CAP, where I think sync scheduling has been considering how to group pods together, kind of like it's over encompassing gang scheduling. And yeah, I mean, job set so even though MPI job, like one of the Kubeflow training organization that does have V2, which is based off of job set. So part of the idea is for job set was to kind of make that a more critical component for training, both for Kubeflow and for non-Kubeflow users. So for training, we could add this in the job set, and that could eventually percolate for the future MPI job that the Kubeflow team has already worked on. So that seems to be like one approach, because right now I don't see of anyone discussing like a distributed job trying to go in upstream. So I think no matter what, we would have to think about higher level APIs anyway.
They have leader worker set as well, which they've been focusing on, I think, a little more strongly than job set.
Yeah. Both are valid points, where even though they are upstream, there are a Kubernetes sub-project, and that can be like part of my view would be those are more, we can experiment or add an API there in an easier way than we can do an upstream to show like how to get this to work before we try to go through the process downstream, or sorry, in Kubernetes to try and propose a general API, because I think the tricky thing is I don't know if it's going to work in all use cases.
Yeah, I think you might be able to have the schedulers figure it out, because we have a scheduler that will schedule a group of things at once. But the way job set is under the hood, it's not there. Pod group works, LWS works.
Well, in leader worker set, they're adding a pod group separately, unless you have a fork of that.
No, we're using that directly, and it's working fine.
Okay, well, yeah, I mean, fair.
Okay, sounds good. One last thing on this, with respect to resource claim versus resource claim template. If we have a resource claim and one of the node goes down, are all of them reallocated, or it will take care of just the one that went bad?
So if the node is taken down and pods get evicted and deleted because they are no longer running, then the resource claim will get deallocated. And if a pod gets it gets deallocated, and then if a pod gets recreated, still references the same resource claim, it will get allocated again.
Okay.
But that all hinges on properly taking down the pods that are on that dead node. If those pods linger and are still visible in the Kubernetes API in an unknown state, the resource claim doesn't get deallocated. So the pod must enter the final state of having failed. Okay, Morten had a comment.
I see some hands up. I'll
Yeah.
let the comments finish.
Sorry, my hand was left up.
Yeah, I was going to say that since this question come in the context of like multi-host devices, then if multiple pods across multiple nodes share the same resource claim, then one node going down means that the other pods will still running, meaning that the resource claim will not get deallocated, because there will still be pods running on other nodes that consume.
You're saying if it's a non-node local resource.
Yeah, essentially, yes.
So that kind of indicates the resource claim template as a choice for this use case.
It'll be different then, right? Because then each.
Then it has to go very granular. Okay.
If you want to evict all pods for a device, the device taints would be a way, something to look at.
Okay, sounds good. Thank you for all the discussion. I will probably file an issue to get any recommendation on current possible UX and go from there. The second one is quick. We have this cap we have discussed on the Slack. So currently there are two mechanisms to kind of cap how much solution space it goes through. One is the cell cost, and the other one is a timeout. Are these enough, or are we looking to introduce additional one?
That's what we have, and I don't have any other plans. I think the timeout covers it's generic. It basically covers all evaluations of claim allocation. All different future features that we may add will have that timeout applied. The ask, I think, in that cap was to demonstrate or at least argue a bit that in expected usage of this feature, you are not going to run into this timeout because the number of combinations that need to be evaluated is reasonable. I think that was the ask.
Okay, sounds good. We'll add that. We'll also, I think we have missed adding that you trim down first using existing mechanisms, trim the search down and then add this. So that is also missing. So we'll just add those things and take it offline then. That's it from me. Thank you.
That leaves Ale with some scalability numbers for us. And I think the question that I would really like to see resolved today is, are we happy with the outcome of those experiments for GA, or do we need to do more? I think that's a big question, but perhaps we'll have some kind of answer.
Yeah, I think I'd like to share the numbers first and the issues I am hitting. And I think eventually we will get to that answer looking at the numbers. So if you can make me the host, I can start sharing.
Thing is, I see. Vita, can you make me host again? I think it can only be one at a time. And
I'm host.
I don't. I made you when you started.
Okay.
So you make Ale the host and he can take over.
Okay, let me try that.
Yeah.
Okay, done.
So Ale, can you try to share again?
Yeah. Is my browser visible?
No, not yet. Not to me. Oh, now I see it. Okay. Yep.
Okay, so just some general context. So we have a SIG scalability DRA tab here in the test grid, dashboard. And this particular tab has two jobs. One is without any DRA workloads. This is just normal SIG scalability with the feature flag turned on. And the other one is with workload. And this one has all the tests that we discussed in the past. So this particular test has the ability to create 100 nodes with 8 GPU fake test GPUs each, and then fill up 90% of the capacity, so 720 devices with first phase, and then remaining 10%, that is 80 devices, in a churn mechanism. So we'll be looking at this particular test today. And so you can see here that all of these tests are ending in failed state. And the reason for that is that when the first phase starts, which is the fast fill, so we are filling up 720 720 devices with 720 pods. the latency the test observes in pod creation to run goes to 5.16 seconds. This is just a little bit above 5 seconds. 5 seconds is the SLO that Kubernetes has been shipping with for pods to create and run. And because this is strictly defined SLO in the perf scale test, these jobs are failing here. I want to pause here if anyone has questions.
Yeah, I think we alluded to that in some online discussions. This SLO of 5 seconds, that is for stateless pods. Basically, the simplest thing that you can run on Kubernetes with no external dependencies other than what Kubernetes itself provides. An exception already was made for pods using volumes, and I think the same exception needs to apply to pods using DRA. They are, in my opinion, allowed to take longer to be scheduled, and they are allowed to take longer to get started on the node.
Okay.
We basically have to have a different. First of all, I'm not even sure whether we can define an SLO, but if we pick something, it definitely can be higher than 5 seconds.
Right. So the issue that I'm currently facing is that because these jobs are in failed state, we can go look back at the data, and most of them that I have looked at are around 5 or in between 5 and 5.5 or 5 and 6. So we have at least like 30 jobs that we can go look at and find out the right, ballpark number. But until and unless we don't go and bump this threshold, these jobs will continue to be in failed state. And because of that, we are not able to graduate this test to, let's say, 5,000 nodes. So I think the first immediate blocker is, for me at least, is to look at, get a reviewer on this particular PR so that we can bump up the limit, get this test green so that we can promote it to 5,000 nodes. And I think, Patrick, if you can help me find a reviewer, that would be helpful. I think Wojtek was helping me with all the perf scale tests, but he is going to be out for some time.
I don't know who else is maintaining perf-test, to be honest.
Okay. In that case, can I start a thread in SIG scalability and we can find
yes, of course. Yeah.
on Slack? Yeah, I'll CC you.
That would be the right approach. Try to see whether any other maintainer of that code from past PRs or reviews is available. I don't have any authority in that repo.
Okay, fair enough.
I've contributed to it, but that's all.
Got it. Yeah, then we can.
Can I ask a quick question?
Yeah, sure.
Do you know where those 5 seconds are spent? Is that CPU bound?
Yes, that's what I'm going to next. So to drill down those numbers, in the perf scale test, there is an artifact directory. In that artifact directory, we have all the observations. So currently, we are looking at pod scheduling latency. So looking at the scheduler metrics and then looking at the pod startup latency. Startup latency is just a watcher. So when the client sees that the pod is in running state, it will note that latency, right? So when that pod goes to running state, the client will note down the latency. Now, in order to drill down, we should look at the scheduling latency. And in the scheduling latency, there is a current issue where the scheduler, the highest bucket that the scheduler reports the latency is at 0.02 seconds, 0.022 seconds. And after that bucket is infinite. So between 0.02 second and infinite, we don't have any granularity of what the scheduler took, how much time the scheduler took in order to schedule this particular pod. So
That's interesting.
again,
That's a classic of not so ideally chosen histogram buckets. Yeah, thanks for sharing.
Yes. So I have an issue open. I think there is another issue that is similar to this, that SIG scheduling is tracking, but unfortunately, the PR for this has not moved forward. So again, I think this is an open work item that will block getting more information about how much time scheduling is taking. And
Sure. Sorry,
I think.
Want to comment?
Sorry, go ahead.
I think I'm asking, and for persistent volumes, the comparison is great, but a big difference probably is we have to spend time waiting on an external system, almost like an IO-like fashion, doing nothing. And in this case, we might actually be doing significant amount of CPU work, which might change the picture a bit in terms of lifting the SLO, right?
Right. So in this case, the external system is the example DRA driver, which is essentially not doing anything as of now.
No, I think the pre-bind operation with volume binding is where it actually talks to a CSI driver and waits for the volume to be attached. So there is indeed, I think, in the volume binding pre-bind phase, some external communication with a control plane component of a CSI driver. We don't have that yet with DRA. With DRA, it's just a matter of recording the resource claim status, which is what happens in pre-bind, but it's not blocking. It's just, well, it is a blocking API call, but it shouldn't take as long as the volume binding example that you picked here.
Well, so you're talking about the external integration in scheduler, right? But if you look
Yes.
at the entire end-to-end workflow,
in the in the end-to-end flow of getting a pod to run, there we have the local gRPC call. So that adds overhead, and that's in fact the component where Kubernetes basically can't predict how long a pod will take to start, because it is depending on a third-party component with some unknown time to prepare resources.
Correct.
But this example, these histograms here, I can see that they might be the histogram buckets might not be appropriate, say, for the filter operation. And that would be interesting to know, perhaps, whether that also has the same problem of too many things in infinite. And it could be. I've seen this issue, I think, reported before, not specifically in the context of DRA, but in general. The problem is that the buckets are kind of part of the Kubernetes API. On the other hand, these metrics are not beta even yet. I remember discussions. I don't remember why it wasn't changed.
Yeah,
I think now that I think about it, I think it was because the SIG instrumentation wanted to have a different mechanism for dynamically resizing the histograms. I think it's something like that, but that's a new feature that is not available yet. So instead of changing the current hard-coded set of buckets, I think the conclusion was to go for something better, and that hasn't happened yet.
Yeah, that is correct. I think that histogram SIG scheduling is hoping for a more leaner version of histogram, and that is not happened yet. But regardless, I think this is another thing we need to go to SIG scheduling and explicitly say that this is, hindering progress on the SIG scale DRA tests, and kind of build a timeline around when it is happening, or when that feature is merging, so we can leverage it here in getting those numbers.
Yeah. Well, it won't happen this cycle. It will not happen the next 2 weeks before code freeze. So that'll just have to wait, unfortunately.
Okay. Yeah, so from there, well, before I move on to my next numbers, I just wanted to ask that the comparison between volume binding and in our case DRA is between that gRPC call and the volume binding external call. So the components which make the external calls are different, but that external call is happening. And in this case, in the job and the numbers that we are looking at, that external operation is basically a no-op because of the example DRA driver. Okay, so with that, I want to look at so these are the numbers that we look for the 90% of fill up of the test. Now I want to go to the next phase, which is the churn. And unfortunately, with the churn, the numbers are little bad. Let me get the right numbers. Okay, here we go. So this is the latency for the second phase, which is churning the pods for remaining 10% of the capacity. And you can see the numbers are going beyond 1 minute here, around 63 seconds. And I find this consistent across many job runs. I think I have another job run here somewhere. Well, I lost it in my tabs, but yeah, I can link more jobs and data if needed. But I find that in the 10% churn phase, the numbers are growing well beyond 60 seconds consistently.
One question that I have is, are pods being terminated quickly? Are they lingering for a while? It depends a little bit on whether they are shutting down cleanly and their exit status, or whether there are some options. And at first, that would be something to check, that once a pod really terminates, that it quickly gets deleted and that without any timeouts, because that has been a problem before. I don't know whether it's a problem in this case, but it could be. But yeah, then getting more insights into whether it's really CPU latency that makes scheduling slow in this case. I don't think it would be surprising, because the fill-up phase doesn't show this pattern at all, and it gets closer to scheduling or when it gets closer to filling up the cluster, it's not that different in terms of complexity of finding a new device compared to what the scheduler needs to do when the cluster is full or getting full. But yeah, some additional information would be good about what's happening in that phase.
Yeah, so unfortunately, I don't have the data of how long it takes for pod to be deleted. And also even in this case, I don't have the data of how long it took. Sorry, go ahead.
Yeah, one thing would be in the test, do you wait for the previous pod to be deleted before creating the next one, or does that happen in parallel?
So
how exactly do you churn? How do you detect that it's time to create the new pod?
right. So the way the churn works is I have all the jobs for the remaining 10% created, and those jobs have completion of 10 and parallelism of 1. So each job will run one pod at a time for 10 times. So that gives us a churn of 10. And then all pods have parallelism of 1. So that particular job will wait for its pod to be deleted. But in general, all the pods will not wait for the other pod to be deleted, if that makes sense.
Yeah. Okay. So at the time that the pod gets created, it should be schedulable. Yeah.
Yes.
Yeah.
Yeah, because one that pod was deleted, and the new pod will take its place. So it should be theoretically schedulable. Yes.
Do we have comparable churn data for non-DRA pods?
No, we don't.
Because I'm wondering how well the scheduler handles this situation, if it has ever been tested. I know, for example, that the scheduler, I just saw that the other day, it picks a set of candidate nodes and tries to do scheduling for those. And if it always tries with the wrong nodes, basically in this churn phase, there is a very limited set of nodes that actually can be scheduled to. And I'm wondering how intelligent the scheduler is to figure out that, or whether it constantly tries nodes that basically can't work with no guidance other than, well, I tried that node and it didn't work, and I now need to try again with something else. That could contribute to this, and it wouldn't be that different compared to filling up a cluster with normal pods.
So the issue with creating a job like that without DRA is that in the case of DRA, we are strictly limiting to 8 pods per node. In the non-DRA cases, the scheduler's ability to deploy the churn pods on any node is basically 100 set of nodes, right? So it is very easy for scheduler to just go ahead and churn.
You could make the pods large in terms of CPU and memory, and that way and ensure that the cluster actually fills up.
I see. Yeah,
So
in that case, this particular job that we have with non-DRA workloads, we can extend that job to include this and get numbers for us.
That would be interesting.
Okay. Yeah, I'll note that down.
I remember that we discussed the SLO and that we never really in the wiki and in the documentation of the existing SLO, it only says that numbers or the scheduling delay, but it never really exactly described the experiment that was done to measure it. So I think it was scheduling from an empty cluster to up to a certain number of pods, and all pods were schedulable. But I'm not sure. I don't think we ever got that fully clarified. And now with what you're running here, we are very diligent about covering different scenarios, and I think we find a relevant one that doesn't work as well as hoped, but it's unclear to me at this point whether it's the memory resource plugin in the scheduler or something else that's causing delays.
Yeah, I mean, with that metric missing, it's hard for us to pinpoint whether it's the scheduler or the plugin or what, right? One more thing I have in my to-dos is to add the metric for the plugin here. So we know if this latency is from the plugin or not. That could be, we could find it out with that metric. So that is in my to-do, and I'm going to add that here. So
yeah, that would be good. So we are almost at the end of the hour. I think we haven't had a clear go ahead yet. We will meet again in 2 weeks before the code freeze, so we can still make up our mind, but this kind of goes against what I had hoped to achieve, which is that we can do the V1 graduation quickly to unblock other PRs that also need to touch the API. And perhaps I want to ask my other fellow contributors whether we should be waiting for GA or whether we just accept that we need to revert the order and get other PRs merged when they are ready. And I basically have to rebase the PR that does the V1 to include whatever else landed in the meantime. I think I'll just have to do that.
How soon do you think we can get reasonable numbers here? If it's 1 week, then I think we should still wait. If it's going to come down to the wire, then we should definitely let other things go through.
Yeah, we can do a checkpoint on Slack in 1 week, perhaps. And
do we have any? I think most of the other big features are still probably a week away from being ready to merge anyway.
That may be true. Well, your mixins is, I don't know. I as you know, I looked at your mixins PR, just had some, I think, minor comments on the API, but I haven't really looked at the implementation yet. So yeah, I think we'll just have to look at the current state and make ad hoc decisions.
Yeah,
sorry, go ahead.
I was going to say, Ali, a week from today, do you think you'll have made more progress on this where we can actually report something back?
Well, I can answer that question on Slack. I think my biggest blocker is finding somebody in SigScale who can help me iterate fast on experimentation. So once we have that, is when I can answer that question. Sorry, it's vague.
Yeah, no, it makes sense though.
In terms of timings, I want to say again, like when we measure the time, the duration of an overall operation, like overall duration of an operation, the next important thing is to find the dominant contribution, right? And as far as I've listened to the discussion, we haven't quite expressed that knowledge yet. So where do we spend the most of the time? I think that's even more important to know than if we are over or under a certain arbitrary threshold, right? If we know where exactly we spend the time, we can say if it's sane or not, right? And we know exactly if it's tunable in the future or not, and how much effort it will be.
Yes, I 100% agree. Sorry, quick comment. The two variables are kubelet plugin and scheduler. The scheduler, we already know it's not happening this release cycle. So the only data point we'll have is a kubelet plugin, and I'll make that happen. At least raise that PR.
One comment. So with one potential suspect would be the filter operation taking too long. But it can't take longer than 10 seconds because I think you are running against Kubernetes master. No, and Kubernetes master doesn't have my filter timeout PR merged yet. We should get that merged and include it in your jobs and see whether it triggers. But yeah, I need API review on my scheduler configuration change, and that's blocking me from getting that merged. It's not the GA graduation PR that comes later, but just the PR that adds the filter timeout. That's also pending an API review, and I'm waiting for the review.
Can we make that a GA blocker?
It is a GA blocker. That's why I want to land it soon. Yeah, we all know how problem or difficult it can be to get reviewers.
Yeah, I think we can try our best. I know at least that from my side I can try and see where it is. We can checkpoint in about a week on Slack.
Yeah. Okay. Thanks. I think that's good closing comment. Let's keep working on this. Thank you. Bye.
Thanks, folks.